Oops. Oh, let's see. We need to go over our schedule really quick. Okay, so tomorrow is the last day to turn in your lab. A lot of us still haven't turned in our lab, so I'm a little bit concerned about that. Tomorrow is the last day. If you haven't turned it in, make sure you turn it in. If you turn it in today, I will try to grade it. You can still do corrections, but tomorrow is the absolute last day for lab 1, okay? Lab 1 and the pre-lab. And then when you come back on Wednesday, you need to have the pre-lab for lab 2 done before you can go into the lab, okay? So that's kind of our schedule for the week. Then we'll do our review for chapter 2, and then next week we'll have chapter 2 test. The other deadline this week is the Alex chapter 2 is due, so make sure as you're going through, as we are going through in class, you need to go through in Alex and make sure you're getting those topics done, okay, if you haven't done that already. Questions about our schedule, our agenda? Okay.
Wait, when's the chapter 2 Alex?
Thursday night.
I got that.
You got it. Great. Now to our side. So this is the last day of chapter 2 notes. After today, you will be able to do all of the Alex topics. So we're going to be talking about electron configuration. So let's remember, if I have germanium-74, it's a neutral atom. How many electrons? So remember, this is the mass number. That's tricky. That throws people off a lot. So what's 74 is the mass number? Oops. What does the mass number mean? Good, yes. Mass number is the number of protons and neutrons. Protons and neutrons. Okay? So if we have germanium-74, how many protons?
32.
How many?
32.
How do you know that?
Because it's atomic number.
Okay, good. So 32
Number says the
is the number of protons. Okay, we look at the periodic table. You will have the periodic table on the test. Okay, so how many electrons would it have? If
it
it's
would have
neutral.
32, so it stays in balance.
Good. We need also 32 electrons. Okay, very good. Today we're going to talk about how to organize the electrons. Okay, this is like accounting in chemistry. So our electrons are in orbitals, and these orbitals are three-dimensional regions where we expect to find the electron. Okay, we have 4 different orbitals. We're going to mostly stick with the s and p orbitals, but there are 4 orbitals. We have the s orbital, p orbital, d orbital, and f orbital. Okay. So in general, this is the pattern.
We need to know that.
You need to know this. You need to know the order of the electron filling, okay? And this is something that you either need to put on your note card or you'll need to memorize. As we go through, we're going to talk about why this is. Why is this order the way it is? But I just want you to have it down first. So this is read 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10. Okay, we're going to talk about some strategies for remembering this, but I would probably just put this on my note card, at least for the first test. There is also one of these on the final. So as you use this more and more, you start remembering the order and what the numbers mean. But for now, if we all have it written down, that'll help to start. Okay, it also matters that some of the numbers are superscripted. So watch out for that. So make sure that the big number, the number in front is like full scale, and then the the letter is the orbital, and then that other number is superscripted. So up above, that does matter. Okay, so this is just an overview. You don't need to know this. I just think it helps us understand that thing we need to memorize if we know where it's coming from, okay? So these are our different types of orbitals. We have an s orbital, we have p orbitals, we have d orbitals, and we have f orbitals. The s orbital is just spherical. The p orbital is like a dumbbell shape. It has two little, they call them lobes. The d orbital has 4, and this one is a little bit different. So these orbitals come from, have you guys heard of Schrodinger? So this, yeah. Okay. This is what he's predicting. This is his model of that. Okay. So these pictures are probabilities of where we expect to find the electron. So it's like an electron cloud model. Okay. S orbitals, depending on their energy, have different sizes. Only 2 electrons can fit in any given orbital. So if we look at this orbital, these orbitals, any orbital can only fit 2 electrons. Okay. So s orbital is spherical, the p orbital. Each p orbital has 3 orbital pieces. And remember, each orbital can fit 2 orbitals. So each p orbital can hold up to 6 orbitals because there's like 3 different types of p orbitals on each level. Okay, you don't need to know this. This is just like, this is where those numbers you're going to memorize come from. Okay. And then the d orbitals, there's 5 different orbital geometries in each d orbital. Each orbital can hold 2 electrons. So we've got 2, 4, 6, 8, 10. Each d orbital can fit 10 electrons. 2 in each of these different shapes. Okay. These orbitals, as we are going through, these orbitals predict how things are going to bond together. So like, if you take an inorganic chemistry class, you talk about this d orbital is going to collide with this d orbital, and that's going to create a bond. Or like the dz orbitals are going to come together, and that's going to be where the electrons are interacting. So you can go pretty deep in this. This is just like, you don't even need to know the geometries. It just kind of, this is where it's coming from. And then f orbitals are really complicated. The lambda-9s have f orbitals, and those have 7 different geometries for each level. So in one energy level for an f orbital, you can fit up to 14 electrons. Okay. All right, so this is how we're going to fill our orbitals, and this is the rules for filling, but you can also just memorize that order, okay? This is what the order is telling us. First, we're going to fill the lowest energy level. So I like to think that electrons are lazy. They like to fill the lowest energy level first. When you're filling orbitals of equal energy level, so if you're going to fill the p orbital, you put 1 in each p orbital, and then once the 3 orbitals each have 1 electron, then you go back and put an electron in, you pair them up. It takes energy for electrons to share an orbital, so they don't like to do that. Okay? So first they're going to be by themselves, then they can share an orbital. And then when 2 electrons occupy the same orbital, so if you have to put them in the same orbital, you're going to put 2 in one orbital, then you have to flip. One has to have spin up, and one has spin down. And I'll show you how we show that. And that's why you have to flip the spin, so that's why there's a little bit of energy involved. Okay, and this is just like an overview. We don't really need to know this, as long as you know that the 1s2, 2s2, 2p6. Okay, so this is a diagram of the orbitals. So we've figured out from experiments, the 1s orbital is the lowest energy, and then it goes to the 2s, and then we have the 2p orbital. Remember, there's 3 different shapes for a p orbital, so we can fit 2, 2, 2, that's 6 electrons, and then it goes 3s, then the 3p. So the order that we have written down on our paper matches the energy order. So we're going to start from the bottom and then we fill going up the chart. Does that make sense? Once we get to, so these are all the same energy level. So that's the second rule. We're going to put an electron in each of these and then go back and fill double. Okay. So here are some more charts. This chart, you just like diagonal. If some people like to use this one doesn't make sense to me very much. So you just like start here and then you go back through. So it's 1s, 2s, 2p, 3s, 4p, 3p, 4s, and you go this way. That doesn't make sense to me, but if that helps you, I posted this on the Canvas course, so if these are helpful to you, you can use that. You can also just use that thing that we wrote down at the beginning. All right, I think that this is helpful. If we look at our periodic table, we have these different blocks, and these blocks tell us what electrons are being filled up, okay? So if we're over here, then this block is called the S block. So we're filling up S orbitals here. So here, this row, if we look on this periodic table, we have 1, 2, 3, 4, 5. This is the level of energy that we're looking at. So this is the 1 energy level, 2 energy level, 3 energy level, mostly 4 energy level, 5, 6, 7. So as you go down, you're getting higher energy. So first we fill our s orbitals, so the top s orbital. And then this block over here is called the p block. That's where we fill our p electrons. This block in the middle, the transition metals, is the d block. And then the lanthanides, this is where we're filling the f orbitals. Okay. So that, I think this is more helpful to me than any of those charts because I always get my periodic table and I can reason through where my electrons are going. Okay. All right, so we've kind of done some overview. Let's go ahead and do our first example. So hydrogen is in the p block, s block. Okay, so we're going to fill, we're filling in the s orbitals. How many electrons does hydrogen have? Good, 1. So we've got 1 proton, 1, we've got 1 electron. So we're just going to start from the lowest energy level. So we put 1 electron, and this is what an electron looks like. Okay, that's our symbol for electron. And that is that's hydrogen, yep. And then if we want to write the electron configuration, this is how we write it. We say we have 1 electron in the 1s orbital. So this is just for keeping track of where the electrons are. This is how we do that, and that's called electron configuration. Okay, we're good there? Okay, we're going to do a few examples. So that's the hydrogen, electron configuration. Okay, helium. How many electrons does helium have? We're just going down the chart. So good. So we're in 2 orbitals. So, 2 electrons. So first we're going to fill 1 in the s orbital. And then we're going to flip the other one. So now they have opposite spins. We have 2 electrons in the 1s orbital. Now that one's full. So the electron configuration is 1s2. We have 2 electrons in the 1s orbital. That's what that means. Okay. All right. Next one is lithium. Okay. This is another important thing. If we look at the last column, that's the noble gases. Do you guys know anything about the noble gases? They are noble. What does that mean? Good, they don't need any more electrons, they're complete. They are very not reactive. Generally, if we can't get these to react, they're just very inert. And the reason is because of their electrons. So helium has a full shell. Everything is trying to get a full shell. Helium has a full shell, so it doesn't react with anything. Okay, so that's pretty interesting. Just based on knowing where the electrons are, we can predict the reactivity. Okay. Let's do the next one, lithium. How many electrons? 3 electrons. So we're going to put 2 in the 1s orbital, 1, 2, and then we're just going to go to the next energy level, 3. So what would our electron configuration be here?
1s squared 2s.
Yep, good. And this is an instance in chemistry where if there's only one, you still have to put the 1. Some instances, like a lot of formulas, if there's only one, you don't have to put the 1. In electron configuration, you do. So thanks for saying that. Okay, good. So 2 electrons in the 1s orbital, 1 electron in the 2s orbital. Okay, beryllium. What would be our electron configuration?
1s 2s.
We got 4 electrons, 1s2, 2s2. This is not a complete energy level because we have the p orbital, or the 2 orbital is not complete. So this is all on the second energy level. That's not a full orbital. Okay, how about boron? What's the electron configuration? We're just moving right across the periodic table. 5 electrons.
So
Good. 1s2, 2s2, 2p1. One way to check and make sure you've got the right number of electrons is you just add up the superscript. So 2 plus 2 plus 1, that's 5. Boron has 5. And that you can check that way. Make sure you have the right number of electrons. Okay, how about carbon? What are we going to do? Good. And if we were drawing out the electrons, I don't think Alex makes you do this, but if we were drawing out our electrons, we would put them all in separate boxes before we start pairing them. Okay, so 1s2, 2s2, 2p, 2. Okay, next one, nitrogen.
1s2 2s2 2p3.
Good. Okay, good. So see how they're all unpaired, and then the next one, we're going to start pairing them. Good. 1s2, 2s2, 2p4. Are you guys under?
Revelations.
Okay, I can't tell if you're mocking me or not.
Oh no, I'm not talking to myself.
Okay. Okay, and then here we are at neon. Neon's second energy level is full. So now it's a noble gas. It doesn't like to react. Okay, so 1s2, 2s2, 2p6. Okay, questions on that? All right. So on the test, I don't know about the Alex homework. On the test, we won't go past argon. So if you can do up to argon, you're good. So I think on the test it might make you do the d electrons, but I don't remember. Okay, go ahead and try atomic number 20. Try the electron configuration. So that's calcium. Oh, this is what I was going to show you. I can't remember why this is linked. If we go to the ptable.com, it has this listed out for you so you can check. You can't just check on the test, but you can check while you're doing your Alex homework. Oh, I know that. Okay, so if we're looking at 20, we're looking at calcium. We can see, and we click on electrons at the top. So you've got properties, electrons, isotopes, compounds. We click on this electrons at the top. Then it shows us the electrons filling. It shows us the expanded electron configuration. And then there's this abbreviation. So we know once we hit a noble gas, you can say like, oh, this is the electron configuration for that noble gas. And then you just add what else you have besides that. Does that kind of make sense? So that's an abbreviation. You can just say, oh, well, if I'm at aluminum, I know neon, so I can just say neon, and then I do 3s2 to 3p1. Okay, so that's what that abbreviation is. I think your Alex homework is going to want you to do the expanded form. The other thing that you can look at is the orbital down here. You can see what orbital is filling and kind of what it looks like. So if I click on like cobalt, it might be a little different. We've got d orbitals now. Europium has those f orbitals. Okay. This is in the p block, so the outermost electrons are in that p block. Okay. Oh, and you can click on what the orbitals look like. Okay. Kind of interesting. So let's go back to calcium. This is what they say the calcium electron orbitals are. It says 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Is that what you got?
Yep.
Okay, great. Let's go back to our slides. Where were we? Okay, we did all of those. Good, good. Okay, then we need to talk about valence electrons and shielding electrons. So valence electrons are the outer electrons. So that last energy level that we are filling is where the valence electrons are. Valence electrons are important because they tell us what is going to be bonding. So valence electrons show us, oh, if we have 6 valence electrons, remember everything wants to be like a noble gas. So if we have 6 electrons, if we get 2 more, then we will be like a noble gas, okay? And then shielding electrons are everything that is not a valence electron. So all the inner electrons are called shielding electrons. They shield the electrons on the outside from the electrons on the protons in the nucleus. So the more shielding electrons we get, the bigger the atoms can get because they can space out away from the nucleus, that positive nucleus. So Alex is going to ask you how many valence electrons certain elements have. So there's a few ways that you can look at this. We're going to look at 2 ways, so you have to decide which way is easier for you to remember. Maybe another minute. Okay. All right. Okay, so one way is to look at that electron configuration, and we look at the energy level. So the last energy level here is 2, the second energy level, and then we count up all of the electrons in the last energy level. So here, how many valence electrons did we have? 6, good. So there's 2 in this orbital, 4 in that orbital. This is the valence orbitals, so we would have 6 valence electrons. Does that make sense? Okay, so oxygen has 6 valence electrons. The other way, let's look at this way first. The other way you can look at this is in a column, they have the same number of valence electrons. So the first column, if we have a neutral atom, those have one valence electron. In the second column, those all have two valence electrons. And then the transition metals are kind of weird, so we just skip those. And then our trend continues over here. In boron's column, they all have 3 valence electrons, 4 valence electrons, 5, 6, 7, 8. Besides helium, helium is a anomaly, I guess. How many electrons can helium have? 2. So it can have 8 because it can only have 2 electrons. So helium is tricky, but it also has a full shell. So it's still a noble gas. But everything else below helium will have 8 valence electrons. Does that make sense? So that's another way. You can either remember, and you can count over. So 1, 2, 3, 4, 5, 6, 7, 8. So you just have to remember to count. You can also write that on your note card. Okay, so now, one of the Alex questions is kind of like this. It'll give you either the electron configuration, or it'll make you figure out the atom identity based on the electrons. So the top one is gallium. How many valence electrons does gallium have?
11.
Good. Oh, this one's tricky. Watch out. So can you see how the orbitals don't fill in order after the 3?
3.
Yes, good. So the last energy level is energy level 4. So we've got 3 electrons. 2 in the s orbital, 1 in the p orbital. Good. Okay, how about the next line? How many valence electrons?
1.
Good, 1 valence electron. And then if this is a neutral atom, what would be its identity? So if it has 3 electrons and it's neutral. Good, lithium. Lithium has 3 protons. This is telling us it has 3 electrons, so that tells us it's lithium. Does that make sense? We have to kind of do like reasoning. It's kind of like a Sudoku puzzle. We don't have all the information, so we got to figure out what the missing part. Okay, how about the next one? If it's neutral, what is the atom's identity? And how many valence electrons? Okay, so 12, it has 12 electrons, good, 12 protons, and then 2 valence electrons, good. So this is our outermost energy level, we have 2 valence electrons. All right, the next one, can you figure out what element it is if it's a +1 ion? So +1 means it has more electrons. Or no, +1 means it has more protons than electrons. So how many electrons does it have? 18 electrons, so it has extra proton. 19, so it's potassium, it's K, good. You guys follow that reasoning?
Yep.
Okay, K. How many valence electrons does this potassium plus have? Good, so you're looking here. This is our outermost energy level. We've got 2 + 6, is 8. Okay, how about the next ion? Can you figure out what that is? Okay, can you explain to us why it's sulfur? Okay, so argon, and then back to, so why did you go back to? Okay, so you're saying that there's extra electrons, and 2 back would be 16 protons, that would give us the minus charge. Okay, sulfur 2 minus, and then how many valence electrons here? Also 8, good. Okay, I think that's it. So before we have some work time, I would like to go in the lab and do a lab walkthrough to make sure that we're ready for our lab on Wednesday. Is that okay?
Yeah.
Okay. All right, let me grab my safety glasses. We'll just grab some safety glasses on your way in. And we'll just talk about the safety stuff in the lab.
Stuff in my eyes.
All right. stay in here for a minute and then we'll go just have work time. Oops. Hello. Okay, right now the air is on. So there's a few safety needs in the lab. So let's start off with like just generally in the lab. In the lab, you shouldn't sit on the counter because there's probably trace samples on there. You don't want to sit on the lab because that's not a good lab hygiene technique. The other thing that happens a lot in the lab is glass will break, and that's okay. That just happens when we break glass in the lab. There should be a dust can. My yard has one, and our break. You can just sweep it up, and then we want to put it in a box. So there's a box over there. We don't want to put it in our garbage can because our janitors take out our garbage, and so if we put it in part of the box, then I can take it out when the box is full, and I can put it in the garbage. And I know that there's broken glass, so I know that I should be careful. So we don't put it in the garbage. Okay. Another thing that we're going to do every time we're in the lab, when we're doing an experiment after we're done, we need to wash our hands before we just make sure that we leave all the chemicals in the lab. This next lab we're just going to be using water and salt, but still we're going to be touching the counters. We're going to be using the lab equipment, and we don't know how well the person before us cleaned that, so we always just be safe and want to make sure we wash it. Thank you for wearing glasses. Even if we're doing just like a non-facility lab, we want to make sure that we're wearing glasses. Okay. I'm gonna look at this back here. This is our fire blanket. So if we have someone that caught on fire, or we have a very small fire on our lab bench, we can use the fire blanket to help smother the fire. So it's not very big, so it would be obviously we can put out a very big fire. So we would just put that over whatever was burning. Another thing that you can do is if it's like kind of a small area and you have a really big beaker, you can take your beaker and you can put a beaker over the something that's burning up to the fire. This can also be used to help stop spills. So we had a pretty big spill of a chemical. You can also use that to stop the spill. Okay. Alright, and if you don't have a fire extinguisher at your house, you can also get a fire extinguisher. Small house fires. Alright, over here we have two different devices. We have a safety shower. This is really serious. We don't want to use this, but we have it in case of okay. So if somebody got spilled on like more than half of their body, we would take them over here and we would shower them. So you just pull this shower thing down. It locks the water on. So if you wanted to turn it off, you would have to physically move that lever back and shut it off. So that's kind of key. You don't want to joke around with this. The other thing is we don't have a floor drain. So if we turn this on, it's going to go all over the floor. And so we are okay with that if we need it, but we don't want to pretend like we're pulling this. We don't want to ever accidentally pull this because we want to right now. The other thing to know about this is if we have to pull you over here and shower you off, then we also have to cut your clothes off because the chemical, you want to get the chemical out of your clothes and your sleep. Okay? So that's really serious. We don't want to do that. We would use the fire blanket as the privacy, but we need to get, if you have a lot of chemical spill on you, we need to get that off so it doesn't burn. Okay? That's pretty serious. This is the eye wash station, so if you got something in your eye, you can still get something in your eye and with your goggles on, but the goggles help a lot. This, you can come over here and you rinse out your eyes. You guys remember how long? 20 minutes. There's a paddle over here. This one does is connected to the drain, so it doesn't make sense. So you push the paddle, you stick your face in. If you have something in your eye, you probably won't be able to make it here by yourself. So tell someone like, hey, I got something in my eye, we can bring you over. Tell them if you have a contact, the same thing. This one looks pretty clean. I don't know if it's really on. But my husband got something in his eye at work, and he went to use the eye wash, and it came out brown. So don't stick your face in it if it's coming out brown, okay? So make sure you get it out so you see your face. So you might need something to check. Okay? That's our eye wash. There is also an eye wash in my classroom up by that front lecture desk thing. So, any questions on the eye wash? Safety shower? Okay, let's walk over this way. This is our fire extinguisher. If you feel comfortable and there's a small fire, you can use the fire extinguisher, but you don't have to do that. You're not responsible for that. If we have a fire, we can probably use the fire. This is the gas. We put a lot in this box. So, if the gas light is on, the gas is on. So when the light is off, not using gas. To turn it off, you just push it in. Okay, so you shouldn't be worried about the button that for some reason I can't turn off the gas if you have an emergency. Just push it in. Alright, this is our key push. You put it still on. Sometimes when you get some here, it'll say like you have a chemical. If you don't know what a chemical is, it might be in the hood. So you'll just come over here, bring a meter from your station, fill up the meter on the fountain. Then check it out. Like, sometimes if you're working, and I don't know somebody's right behind you. So if you see somebody working in the hood, don't stand like right behind them, or make sure they know where you are, so that they don't turn and take you. Okay. So you probably see the traffic around you. There's a few scales over here. The second lab is working over here. You like I pretty this kind of scale. Over here, we have our exhaust button. This is what circulates our air below your this is okay, I remembered one more thing. So for our lab, we need long pants and closed-toed shoes. So some of the labs, I won't be super strict. So this first one is like not super strict, but some of the labs, any lab that we use like serious chemicals, then you're gonna have to wear long pants and closed-toed shoes to the lab. And I will do a remind notice so that you remember, hopefully you remember the night before. Are you guys getting the remind notices?
Yes.
Okay. Okay. Are those helpful?